Hello everyone, sorry I couldn't be there today, but I wanted to go over two main topics from our new section, Can You Tackle Tongue and Evil Eyebrow, Day 2. So, there are two main topics I want to focus on. I'm not going to be answering every question as we go through. You should be able to answer that first question, number 2. Go ahead and make sure you're writing out with those basic fractions. And we're going to jump right into question number 3. Given that a person selected is yes, evil eyebrow, what's the probability that they are a yes, taco tongue? Now, what this does is this gives us a condition. Our condition is that they're a yes, evil eyebrow. Okay, that's our condition. That's a requirement for them to be. So if we take a look up here, our condition's right here. And so we're not dealing with this out of the total 11 people. We're dealing with it during the limited 5 people who are yes, evil eyebrow. And then we're going to look at the probability of that. So this is our first conditional probability. We would write it like this. The probability that somebody is a yes, taco tongue, given, and this given is actually just a bar, given that they are a yes, evil eyebrow. Okay? All right, so what's the probability that they're a yes, taco tongue, given that they're a yes, evil eyebrow? And we're going to write our probability out as a fraction. Now, because that condition exists, we have a limited pool to go from. We're not going from the total 11 that most of our probabilities have been before. Our new total is out of that 5. So that's going to go right on the bottom here. And the yes taco tongue isn't going to be 8. You can't even have a probability that's 8 out of 5. It's going to be just those within this column of the yes evil eyebrow, within this condition. And we can see there 4 out of 5. And there we go. We've got our probability. Now this is a fraction. You also want to write it as a decimal, which is 0.8, and then express it as a percent, which is 80%. And we would communicate it like this. There's an 80% chance that somebody who can do the evil eyebrow can also do the taco tongue. All right. Go ahead and try and do the conditional probability for number 4. Then we're going to get to our second big thing for you to make sure you learn well. Okay? Pause the video as you work on question number 4, and we're going to go to question number 5 in 3, 2, 1. All right. 2 events are independent. Now, independence is a very important thing in probability, and if 2 events are independent, then knowing whether one occurred doesn't affect the probability that the other event also occurs. So let's take a look and see if in our situation, yes, taco tongue and yes, evil eyebrow are independent. So first, let's take a look at the probability of yes, taco tongue. And if I just look up here, the probability of yes, taco tongue is 8 out of 11. 8 out of 11. Okay, I believe plugging that in would give me, I think, 0.777, I think. Let me just double check. I'm probably wrong. 8 divided by 11. 0.7272. 7273. 0.7273. And that translates to roughly a 73%. Okay? And it is an approximate, so I'm going to put those wavy lines right there. Awesome. Now, let's see what it looks like with our condition. Okay, what if we do yes, the probability of yes, taco tongue, given that we know that somebody chose evil eyebrow? That is equal to what we already did, 4 out of 5, which is 80, or 0.8, which translates to 80%. Okay, so in looking at that, it doesn't look like these probabilities are the same, and that's what we're ultimately going to look at. This is a 73% chance, and this is an 80% chance. They're not the same. Since our probabilities are not the same, These two events are not independent. Now, because our sample size is so small and these numbers are pretty close together, we could default and say statistics aren't perfect, so maybe they are. And this is where we're going to look into the other one. For the events to be independent, they can't influence each other. We only looked at whether evil eyebrow would influence the taco tongue. So let's try it the other way. Let's do the probability of yes, evil eyebrow. And for evil eyebrow, that's 5 out of 11. And that should translate to 4, 4, 4, 3, something like that. 5 divided by 11. 4, 5, 4, 5. 0.4545. And that translates to a 45%. Okay, so let's add the condition on it. The probability of yes, evil eyebrow, if we know that condition that they're yes, taco tongue. Okay, now this is our conditional probability. So let's take a look up here. Yes, evil eyebrows there, but yes, taco tongue is this one. So we have 8 and we've got 4. So this is going to be 4 out of 8, which is equal to 0.5, translates to a 50% chance. Notice that these are pretty close together. Now, depending on what you're specifically looking for, you may say, again, that statistics aren't perfect. These probabilities are pretty close together because our sample size is so small. But because they're not exact, in this case, we're going to say, no, these two events are not independent. But sometimes we'll have to use discretion for that. Okay? Since the conditions affect the probability, the events are not independent. Now, independent events are really useful for us. If we have independent events, then we can actually do a lot of extra shortcuts and things like that. So we generally like independent events. If we don't have independent events, we probably don't like it all that much. All right. So we want to find independent events and estimate what they are. All right, so go ahead and take a look at the data here given for all seniors. Go ahead and fill it out and specifically take a look at the yes, taco tongue, and evil eyebrow, and judge whether those two events are independent. Does yes on the evil eyebrow affect the probability of yes for taco tongue? Now, as soon as you finish that, we're going to go on to this one, and I want you to think, what would the probabilities have to be if they were independent? So, notice here, yes, taco tongue is 480. What would yes, evil eyebrow have to be in order for these two events to be independent? What would each of these probabilities have to be? Go ahead and see if you can find those out, and we will talk about that a little bit later. But compare your answers in question 6 and question 8. I hope you have a good rest of your day. Don't forget to complete the check your understandings. Practicing conditional probability and independence in probabilities is an important skill. So do that check your understanding, and with your remaining time, work on any other check your understandings. Have a good day.